Hey everyone, welcome back to my channel. In this video, we are computing section number 4 of our data science question paper, which focuses on quick conceptual understanding. Let's go through each questions with simple explanation. Let's moving ahead. So question number 1, what type of scaling transform a skewed distribution into a more normal distribution? So when data is heavily skewed, we don't want to apply normal scaling directly. Instead, we use transformations like log or power transformation to make the distribution closer to normal. Now next question. Name two regularization methods used to improve linear regression models. So in linear regression, regularization helps reduce overfitting. The two widely used methods are lasso, which uses L1 penalty, and second one is ridge, which uses L2 penalty. So question number 3, how does stochastic gradient descent differs from standard gradient descent? So basically, standard gradient descent uses the whole dataset for every optimization step. Stochastic gradient descent updates a model using just a small batch or even a single sample. Let's make it much faster for big data. Moving ahead with the next question, what happens to the bias and variance of a model? The regularization tuning parameters is increased. So basically, regularization parameter, that is lambda, controls how much penalty we apply. If lambda increases, the model becomes more simple, so bias goes up and variance goes down. Moving ahead with the next question, what two main type of data measures are used in descriptive statistics? So basically, descriptive statistics mainly focus on two things. First one is measures of centrality like mean, median, mode, and measures of variability like variance, range, and standard deviation. Question number 6. What is the main potential risk when using a non-parametric model which makes no assumption about the functional form? So, non-parametric models don't assume any functional form. While they are flexible, they can easily learn noise in the data, which leads to overfitting. Next question. When using k nearest neighbor KNN, what technique is typically used to find the optimal value for the parameter k? So choosing k randomly can ruin model performance. That's why we typically use cross validation to find the most optimal k value for KNN. Moving ahead with the next question, what is the distance metric that calculates the similarity between two non-zero vectors using the dot product where higher value imply more similar vectors? So for that question, when comparing fixed or high dimensional vectors, cosine similarity is huge. It measures similarity using the angle between two vectors. The closer they point, the more similar they are. Moving ahead with the next question, in the context of the bias variance trade-off, a model suffering from high bias is typically characterized as what kind of fit? So basically in question number 9, a model with high bias is too simple and fails to capture pattern in data. So we call the situation underfitting. Now last question of this question paper, the area under the curve AUC, area under the curve, for a classifier that performs no better than random guessing in a ROC plot is what numerical value? If a classifier no better than random guessing, its ROC curve sits around the diagonal line. So in that case, the AUC value equal to 0.5. And that completes section 4. These are important conceptual questions you will see in the exam and also in your interviews. So if you like my video, so don't forget to like and subscribe my channel. See you in the next session. Keep learning, keep exploring. Thank you.